Now let us start the lecture number 2 in module 12 under the advanced metrology topic. In this lecture we will be discussing about the different types of CMM probes. So we will discuss about the probe working and how the collision of probe with the machine or workpiece is avoided, and then what are the various types of probes like touch trigger probe, scanning type of probe, and then we will also discuss about the calibration of probes and how do we change the stylus or probe depending upon the inspection required, and then we will discuss about the vision probes, and then we will move on to the CMM software, wherein we will be discussing about the various capabilities of software, and then what are the various subroutines used in CMM software. Now let us study how the CMM probe works. In this picture, we can see we have the CMM table on which the workpiece is placed, and then this is the probe. When the probe is moved in this direction, this tip of the probe or tip of the stylus will come in contact with the job, and then it slightly deflects. The probe will deflect like this, and then the we can see here we have three micro switches placed inside the housing of the probe. One micro switch is available here, second one, and one more behind the spring. Now when the probe, when the stylus deflects, the micro switch gets opened, and then a signal is sent to the CMM software. So this is a mechanical probe wherein the micro switches are used, and then we have another type wherein a piezoelectric element is used, or wire strain gauges are used to sense the contact of the stylus tip with the job. Now in the case of touch trigger probe, as the probe contacts the job as shown here, the continuity breaks or resistance changes. If it is a probe with micro switch type, the micro switch gets opened and a signal is sent to the CMM software. If it is a probe based on strain gauges, when the probe deflects, the resistance of the strain gauge changes, and hence a signal is sent to the software. The computer records this point coordinates. That means whenever the probe comes in contact with the component, that particular point coordinates are stored by the computer. An LED light and an audible signal indicates the contact. In the case of scanning probe, this is used to measure contour surfaces and very complex irregular shapes, and this scanning type of probe remains in contact with the part surface as it moves. For example, this is the probe, and say this is the surface work part surface. When the probe moves in this direction, this tip, it scans over the surface, and then it will be sending the signals to the computer system, and hence very complex 3D shapes can be assessed using the scanning probe. Now let us try to understand how the probe collision with the CMM structure or the job is avoided. We can see here we have the table of the coordinate measuring machine, and this is the column of the coordinate measuring machine, and this is over arm on which the probe head is provided. We have the probe fixed to the probe head, and this is the probe rack. Now the workpiece, this is the workpiece to be inspected, which is mounted on a fixture. The height of fixture and the location of the fixture plays a major role. Now when the stylus is checking the inside hole feature, the other stylus, for example, this stylus should not touch the table, and the other third stylus should not touch the column. So in such a way, we have to locate the fixture, and we should select the fixture of proper height. Similarly, when the probe moves, see, it selects the appropriate probe from the rack, and then it will be moving in this direction for carrying out the inspection. So after carrying out the inspection in this particular hole, it will be retrieved, and then it should be moved up to a sufficient height so that this stylus will not touch the surface of the workpiece. So like this, the automatic path selection is done using the CMM software based upon the CAD detail that is provided. So you can see here the probe is inspecting very complex part. So when it after completing the inspection over here, it has to move up to a sufficient height, and then it should be brought to this position for inspection. Now we can see the probe assembly. This is the probe body, which is fixed to the probe head using the spanners, and then we have this is the probe module, which can be coupled with the probe body using the kinematic coupling. We can see the alignment marks here to check whether the assembly of the probe module with the probe body is correct or not, and then we can select the appropriate stylus, and it can be fixed to the probe module. The term probe refers to the entire probe configuration, and the term stylus refers to the stem and tip of the probe configuration. So this is the stem portion, and this is the tip of the stylus. Now let us study the different probe types. Under mechanical probes, we have touch trigger probe, scanning probe, and 5-axis probes. This touch trigger probe, it contacts the job at the selected points, which are decided by the operator or by the inspection program. The operator operates the joystick, and he will move the probe, and then probe will move and it makes contact with the workpiece, and then like this measurement is carried out. If it is CMM with a dedicated computer system, these selected points are decided by the software or the inspection program. Now the scanning probe, there is continuous contact of the probe tip with the job, but this can also be used as a touch type probe. And then we have 5-axis probes, the details of which we will be discussing shortly. And there is another type of probe called optical probe or vision probe. So you can see here this is a profile which is to be measured. So the probe we have to select the scanning probe. It continuously it moves over the profile, and then it will be sending the data points to the computer. Now touch trigger probes, they measure discrete points decided by operator or the software, making them ideal for inspection of 3D geometric parts. Now, as the probe touches the surface of the component, you can see here probe will move and it makes contact with the workpiece surface. So as the probe touches the surface of the component, the stylus deflects and simultaneously sends the XYZ coordinate information to the computer. Now you can see here this is the stylus and this is the probe module and probe body. So depending upon the inspection, we have to select appropriate stylus and appropriate module which can be assembled into the probe body. And care must be taken to see that proper stylus with proper tip and stem length is selected. You can see in this particular diagram, the stem is contacting the workpiece surface, which is incorrect. So whereas here only the tip of the stylus is contacting the surface. That means we have to select the appropriate stem and tip for achieving the proper measurement. Now in the case of continuous contact probe, these scanning probes are miniature measuring machines that can acquire several hundred surface points per second. That means such as the speed of acquiring the data points, several hundred surface points are sensed in each second, enabling measurement of form as well as size and position. Scanning probes can also be used to acquire discrete points similar to touch trigger type. Now you can see here the probe, when it moves like this, it is scanning the surface, and hence we can get the profile information. Very high speed scanning is possible with advanced scanning probes, which can sense at the rate of 300 millimeter per second. An extremely robust design to withstand moderate collisions. The low probing forces give maximum application flexibility. Because of this low forces, the wear of the stylus is also very less. An excellent product life with a mean time before failure in excess of 50,000 hours. So this gives low cost of ownership. Now let us discuss the 5-axis probe systems. In conventional coordinate measurement methods, the CMM structure performs all the movements, that is X, Y, Z movements necessary to acquire the surface data. CMM structure accelerations induce inertial deflections into the machine frame, which in turn induce measurement errors. Many techniques have been developed that reduce these dynamic errors, but there is an upper speed limit imposed by the machine and servo system stiffness, beyond which measurement cannot be taken with reliability. Recently, 5-axis probe system have been developed, which uses an articulating head that moves in 2 rotary axes as it measures. That means